Hello everyone, welcome to my YouTube channel IndiaGATE. This is Nandani Sharma. In this session of TOC, we talk about complemented finite automata. So before starting of this session, if you are first viewer of my YouTube channel, please subscribe and click on bell icon for all notification of my videos. And others, keep on like, share, my videos. So let's start. Complemented finite automata. So this is very easy concepts because when we interchanging the final and non-final states of any finite automata, we got the easily complemented finite automata. So in the previous session of TOC, we talk about various types of question which is divisible by 3 or 4 or more than other numbers. So firstly, we draw a finite automata which accept all number of a's which is divisible by 3. So we got this transition diagram. After the converting into the complemented finite automata, we got this, and this is represent number of a that are not divisible by 3. Move on, second question. Here complemented grammar is already given, and if you are complement a verb DFA, then language accepted by the DFA is here the 4 option. A, start with A or 0, and with A and B, contains at least 2 B's, and option D is not, means none of these. So after the converting the given complemented grammar into the finite automata, we got this transition diagram, and this represent all the string of A and B's where substring is BB must be included. So we say that none of these satisfy this language or finite automata. Now comes to the next question, which is asked in GATE. In this question, the complemented DFA is already given. Let S denote a 7-bit binary string in which first, fourth and last bit are 1. Then how many number of strings are there is language accepted by a verb complemented DFA form? So options are A 16, B 8, C 7, D 9. So come to the solution. After the interchanging the final state into the non-final state and vice versa, we got this finite automata. Here specify S include 7-bit where first, fourth, seventh are 1. Now total number of string from second, third, fifth and sixth 16, all the combination of 4. So after we say that these are 0 0 0 1 1 0 1 1, and here also say that 0 0 0 1 1 0 1 1, means total 4 combination from second and third string and 4 combination from fifth and sixth string. So here 8 combination of third, second, fifth and sixth bits, and excluding the 1, we got total number of string is 7, because in the case set repetition is not allowed. So we total number of 7 states. After this is option C. 7. So this session is end here. I hope you understand all the points. Thank you. Have a nice day.